Good afternoon, everyone, and welcome to the Raspberry Jam Live. This month's jam is part of the annual Northern Ireland Science Festival, and in the spirit of science, we've decided to theme today's activities around space. We want to briefly apologise as well for the delay, but everything so far is all working and green lights. If you have any questions or any issues at all, please let us know in the live chat, and we will have a member of our team look into the issue and make sure we can resolve it. Today, we'd also like to thank Nitech Solutions Limited again for allowing us to use their really cool office space, as well as their workshop, which we are in currently. We want to also thank the staff who helped prepare the night before we came to make sure this event ran as smoothly as possible. We'd also like to thank Dave Hoeness from the European Space Agency for taking the time to do an interview with us, and who will also be joining for a live Q&A from Amsterdam to answer your questions. Now, today's schedule starts with this workshop, which will be the AstroPi Mission Zero workshop, and you'll be guided through on how to write Python code that will run on your laptop, but will then be sent to a Raspberry Pi on the International Space Station. After a short break, there will be an interview with Dave from the ESA, or the European Space Agency. Our second workshop will be Mission to Mars, where you'll have the opportunity, no pun intended, to run remotely your code on our BitBots. We rovers are currently out in the hall, and they'll be exploring the Martian terrain. To finish today's event, though, we'll be having a live Q&A session with Dave, so you can prepare your best space-related questions, type them into the comments, into the screen, and we'll make sure that we ask Dave at the end of our live stream. So, to get things rolling, we're going to do the AstroPi workshop. And for those who have never done it, don't worry, we've got a worksheet and everything ready for you, and we will have everything, any issues, all followed up and resolved. So there'll be a workshop link available shortly, a wee bit.ly link, and it will be posted in the chat, so you can click the link and it will bring you to a PDF of the workshop content. So to give you a brief summary, in the International Space Station, maybe not currently right above us, there are two AstroPis, and one is called, I actually don't know the names, apologies, but two AstroPis, and you can send your code up to them, and they're part of a bigger thing called Mission Zero, which is giving you the opportunity to run your code in space. Now, unfortunately, this competition is only applicable to people who are 14 or under, but doesn't mean you can't do it. The only change is that whenever you put your age in, it will say if you are 14 or under, you get green light and your thumbs up, your code will be checked before it gets sent up and will be sent to the International Space Station if there's no issues. If anyone in your team, which can be one or more people, 1 to 4 people maximum, if anyone is over 14, it will have to be an unofficial submission. You'll get a certificate of participation, but I think the certificates are quite cool. If you can go under 14, they're quite cool. There's a little map on the back as well and your name on it. But that link, posted by Jack Delaney, thank you, is currently on the chat, and it will guide you to a PDF if you want to download that and have that locally. It will give you the link as well for the starting part, which is the HTTPS trinket.io Mission Zero link. That should be a straight click through, and I will also have my assistant, Charlie, available on my other end. If you have any questions, I'll see them on my screen, and some of our moderators will as well, and Charlie will be able to help if she has any issues. We can do it live and debug it, so we'll see how that goes. But I think once we have gone PDF, if everyone has a PDF, we can get started. So, Charlie, can you hear me? Hello, Charlie. Okay, so have you opened up the PDF?
I have it right here.
Okay, so if I can ask you to click on the link at the very top of the PDF, and that should open you a new browser tab with the little code environment called Trinket.
Oh, there, I've done that.
And then, so initially, whenever you click that link, what will happen is you'll be presented with a screen. On the left-hand side will be a code window. On the right-hand side will be a virtual AstroPi. Now, for those who've been physically at the jam, the AstroPi is something you have used before. It's essentially a Raspberry Pi with a sensor on top, and the sensor has a screen, a joystick, multiple sensors that can do different motion. It can detect motion, it can detect humidity, pressure, and also temperature. The three, temperature, pressure, and humidity, you have little sliders above, so you can test your code right in the browser, as well as you can move the little kind of box which actually holds everything. That is a real version or a real kind of render of the one on the space station. It's a big, massive, chunky block of metal, but it will have all the interaction that you can do. You can change all the values, you can mess around with it, and just test your code to your heart's content. But start off the code. The initial couple of lines get us started in the actual program. The first one is the from SenseHat, import SenseHat. Basically, that tells Python to say, hey, we want to connect up and get our library for using the SenseHat. And so Python will scramble away, pick up the library, and drop it into our code so we can use it. Follow it up, it will have sense equals SenseHat and 2 double brackets. And essentially, what happens is your code will say, I need to create a new SenseHat object as such that you can use to communicate with the physical SenseHat. And so Python says, no problem, I'll hand you a SenseHat, we'll call it sense. So you will use sense to interact with the SenseHat. And from there, you can pick up that sense, the word sense, as your variable or your object, and then use that to interact. And the first line to get us started off so that the orientation is correct and it presents very nicely and correctly on the screen is to set the rotation to 270 degrees. And that basically turns it 3 times around and puts it right in front of us. So it's the correct orientation. And the screen will be vertical for us whenever you load in the window. So once that is all loaded in, Charlie,
Yes.
could you do me a favor? You've got the window open and you've got your code there. Good. Let's get started. So to start off, we've got those 3 lines inputted, no problem. But our criteria for this competition is the initial bit, reading the humidity from the sensor. So Charlie, could you follow along with me? What I'm going to type in is I'm going to type in, with reference to the worksheet, if you have any issues, the worksheet should have everything we're doing today. Type in humidity, and we'll use this as a name of our variable. And we will say humidity is equal to sense. That's using our SenseHat object and communicating with it. And it will be sense dot get humidity with 2 little brackets at the end and an underscore between the 2 words. And that tells Python, go get that value for us and store it in the variable called humidity. And with that, you've already passed one of the guidelines. Halfway there. The main thing is that you've used one of the sensors. What we can do now is we can leave that sitting there. Or later on, we could even just, you might be able to print that out later, but we won't get onto that too quickly. We can run our code in the top, just above. I think on Charlie's screen, it should be there. So Charlie, you should see a little run button above their code where the,
Yep.
If you could hit that for me, what do you get? Does it do anything?
Nothing's happening yet.
Oh no. Okay, well, we can fix that. Essentially, what we've got is it reading information, but nothing to do. Well, it has something to do, but nothing to really print out. So Charlie, I think what we're going to have to do is we're going to have to actually print out something. Maybe not the humidity data. We'll work on that later. What we will print out, though, is a nice little message. And so because the code will be running in space, for those who are eligible, the code will be running in space. What will happen is this, if this is the code that you submit, it will print that in space, and the text will scroll across. And what we can do is the SenseHat has a built-in function called showMessage. And so we can use that, pass it a piece of text or a string, surrounded by double quotes, and say, we want to print this text. Now, it doesn't support everything. You can't put emojis or something in it. It might crash, actually. Don't do that. But maybe exclamation marks, question marks, or in the case of the example code, one small step for pi. So what I'll do is I will go to a new line, and on my code, I will write sense Oh,
Sense,
yep,
did you say?
sense.
Okay.
I will write sense dot dot show message. So show underscore message, and what we want to do is just like before we had to get humidity, but inside the contents, inside the brackets, there's nothing. We want to add something into that this time. So we're going to do an open bracket, not a closed one yet. An open bracket. Oh well, Trinket might add in a closed one for you. Don't worry about that. Just make sure your cursor's in between those two brackets.
Yeah, I think.
And what we'll do is we'll use a double quote. And when we open one, Trinket will open another, very kindly. And what will happen is we will get our text. Now, you could put one small step for pie. That's perfectly fine. But you could be a bit more original if you wanted to and use your name. Use your favorite food. You could say you like pie. You could say hello astronauts. And that, that sort of guidelines. Don't put anything too long because it might not actually show up. But maybe your name. Your name should be quite good. And should work no problem at all. So I'm going to put in my name and it'll be Stuart. And that'll be
Am I able to put in like exclamation points or
yeah, you should be able to put symbols in. So
stuff like that?
Little bits of punctuation, commas, full stops and such should all go through. Just as long as they're between the two double quotes and it should all go smoothly. And with that, whenever you have a message ready, in your own time, there's no rush on this bit, what we'll do is we will have our code run whenever we're ready, and it will take a sweet time. It'll just slowly come in. There we are. So my name is now scrolling across my little virtual AstroPi. And with that, you've already passed the criteria. Like, you could submit your code right now. But we don't want to do that. It's a bit lame right now. We can fix that. We can make it much cooler. We can find out. Well, we use the show message. Okay, that's good. We could put a second show message. So we could say sense.show message and then put your favorite food. That text will follow along. It'll scroll across the screen. That's not a problem. But we could be a little bit more inventive. So let's say we use a scroll speed. Or change the scroll speed, sorry. What we can do is, someone's going to put a Rickroll space. What we can do is we can put and change parts of the text. Now, we don't mean you can like scale it up, make it tiny. Unfortunately, you can't do that. You can make it go quicker and slower though. And what we mean by that is your current message. Let's say it says sense.showMessage, and well, it comes up with your name. Good, but I don't know. We can make that better. Maybe something longer. Maybe put your name twice. Put your name with your favorite food or color. And then what we'll do is, because you don't want to put too much time into this one piece of text, we'll make it go quicker and it'll zoom across. And hopefully it won't take 30 seconds. If it does take 30 seconds, just speed it up and it should be fine. So Charlie, would you be happy to get started on that bit?
Yeah.
Lovely. Okay. So your current show message. So if you want, you can create a new one if you want to. Just remember sense.show.
Yeah, I've made a new one. Yeah, I said I've made a new one.
Oh, okay. So message and then contents, and between the closing bracket and the double quote at the end, at the very end, between the closing bracket and the double quote, stick your cursor in there. And once it's flashing in between those two symbols, press the comma. What this is going to do is this is going to tell the function show message that you want to print Sam Stewart or whatever your name is or whatever contents are in it, but you also want to tweak a few things. By default, we can by default the scroll speed is set to 0.1, but the higher, or if you want to make if you make the scroll speed larger, like the number larger, it'll take longer to scroll. So maybe let's set it to something like 0.05, and that should zoom across. So after the comma, we put a space. And what we're going to do is we're going to type scroll, SCROLL, and then underscore speed. And then what we're going to do is we're going to say scroll speed is equals to, so a wee equals sign, and 0.05. And once you've typed that in, just as ever, hit the run button. And hopefully that should go a little bit quicker. And obviously you can test it by going a little bit smaller. Maybe, I don't know what the limit is. I wouldn't want to put it too low because it might, 0.01 makes it zoom across or fly across. So what about 0.001?
Oh, there we go.
Oh, okay, that is quite quick actually. Essentially, 0.01 seems to be quite quick, but okay, maybe you have a shorter piece of text, you want it to stay up longer. We just do the opposite. So, did you get your scroll speed working? And nice and
Yeah.
well, nice and scrolly.
Okay. Yeah, I've deleted the first one, and now I've got my hello world with the scroll speed 0.05.
Lovely. Has that worked out a little bit quicker? What are you printing out of interest?
It's just saying hello world.
Oh, okay. Oh, so you're following the challenges as well. Dead on. In that case, scroll speed, great. Now, let's put it to a larger number. So instead of 0.05, because the default is 0.1, we want to go above that, and that will make things go slower. And it'll take us time going across. So what we'll do is we will put 0.3. And we'll see. Oh, okay, that is crawling across my screen. Eventually it will finish, but you can adjust your speed at that point. So hopefully, and finished. Okay, so that's just finished for me. How about you, Charlie?
Yeah, I've got that.
Has it managed to scroll past, or is it taking its time?
It's taking quite a while. I just stopped it.
So I've not tested this yet, but I don't know what the maximum and minimum value of this is. I would not recommend putting anything like 2 billion or anything like that. But I'll try putting scroll speed equal to 1. Oh, well, no, maybe. What are people putting in for their scroll speed out of interest? And is it like quick or is it slow? It's be very interested to see what the actual like maximum value is such, because I find up to like a maximum of scroll speed equal to 1, that seems to be the slowest it's gonna go. And then obviously the lowest maybe 0.01.
No, you can do I'm doing 0.003, and that works.
0.003. Okay.
0.003.
Oh. How many zeros?
4?
4? Okay, 4 after it.
Yeah.
Yep, that. Okay, I didn't even read the string. I didn't read the text. I'm gonna make that slightly longer. Sam Stewart likes burgers. Nice. And then we're gonna run that and say fly across the screen. So yeah, good. You now know how to scroll speed.
10 zeros.
What we're gonna do now is we're gonna spice it up a little. Not just can you change the scroll speed, you can change the color. It is vastly beyond just black and white. You can put red text, you can put green text, you can put blue background, you can put maybe different backgrounds for different words, as long as you put separate show messages. And what you can use is on the right hand side of the worksheet, there is actually a RGB values list, and it will have all the corresponding colors and an equals and their corresponding RGB values. And essentially, computers will read, or Python will read, those RGB values as being the red brightness, the green brightness, and the blue brightness. So if it's 0, LEDs are off. If it's 255, maximum brightness for that LED. And combined, they will make different colors on the spectrum. So 255, 0, 0, so 255R, 0 green, or 255 red, 0 green, 0 blue would produce just red. And then obviously if you move the 255 to only using 255 for green, it'll make it only green and blue, such and such. If you put them all on, so 255, 255, 255, you get white. and 000, you get black, or essentially the LED is turned off. In the middle, there should be different variations for you to tinker around with, and by all means, in your heart's content, as long as they go between 0 and 255, anything should work. If you want, though, you can copy and paste the contents of the PDF and just drop it into your code. But which one do you think you want to do first, Charlie? Do you want to do the background or the text color?
Let's do the text color.
Text color? Oh, okay. Right. So,
yeah.
For my example, what I'm going to do is I'm going to create a new sensehat.showMessage, but I'll keep my previous one there. I'll just write my new code above it. So I'll skip a few lines and I'll skip the sense.showMessages down a little bit, and I'll put a new one below the get humidity. And then what we're going to do is you know how to get a message. So what we'll do, sense.showMessage. So sense.show_message. And maybe this time, you can put your favorite number. Make sure it's in double quotes though. Make sure it's in double quotes. I will put 2,463,784,009. There. A nice number. I don't remember that again, but it's on my screen now. And what I'll do is I'll make that, I'll display that in blue. So, easy enough. Actually, no, I'll do red because that's on the example, so it should be the easiest to work with. What I'm going to do is, with my new show message, I'm going to put, just as before, I'm going to put my cursor between the closing bracket and the double quote, and I can put a comma down there. Press space, and once you've done that, you're now ready to put in the new text color. So, after the comma, it will be text underscore color, and then we will set an equal sign. Now, the difference between the scroll speed and the RGB values is the scroll speed is just one number. It's a single number, which basically you say set the speed of this text to this. But text color obviously requires a red and a green and a blue value. So you wrap them in square brackets, and that basically keeps it into one kind of set, and you can pass that back as a text color. I'm going to pick red, so I'm going to open a nice square bracket. Make sure it's a square bracket, or it might get upset. And they should be on the right hand side of your keyboard. And I'll put 255, 0, 0. So at the end, it should be sense.showMessage, my message, which is my obtrusively long number, and the text color should be equal to 255, 0, 0, separated with commas in square brackets. And I will hit run, and like magic, my text is now red. How have you been getting on, Charlie?
Yeah, that worked for me.
What have you? Oh, okay. I've got my code after that as I zoomed past. I keep forgetting. Oh, you have any ideas on what other colors you want to try?
Can we try green?
Okie dokie. Yes. Okay. Thankfully, that is actually one of the native values. So, for green, I'll change my text color to 0, 255, and 0. And then if I hit run this time, it's now green. Well, nice bright green. You can maybe, change the colors up a wee bit if you want to. Again, references and examples are on the worksheet. Why don't we try something else?
Would I be able to,
Go for it.
So would I be able to change the color, but also change the scroll speed inside the same brackets?
Genius question. What we can do is we can include both of those inside of it, but just as before, we'll need a comma to separate them. So Charlie, what I'm going to do is I'm going to get my code, and I'm going to go to my example with my text color being changed. And at the very end, just like before, we're going to put our cursor between the closing bracket and the closing square bracket this time. So at the very end, just before the closing round bracket, we'll put another comma there. And so this basically says, change the text color, but also, you want to set the scroll speed, not a problem. we can just do, just like before in the previous example, we can say scroll underscore speed is equal to, and your 0.00003 example worked, didn't it?
Yeah, it did.
Okay, I'm gonna put that down again because I'll make this go really quick. So I make sure I'm within the 30-second limit. Time and space is apparently very limited, but they do want to get the certificates out by June. So 0.00003, right? And we'll put the text color to green. So my 2,463,784,009 number should run. And just like magic, it has run in green really quickly, and now it's followed up with my name, Sam Stewart likes burgers. See, this is the quality content that they need in space to make sure that they are getting through their day. I think there's an example as well, which was created by one of the Jam volunteers, where he created an autonomous snake program. And the code, now this is like Python, you can write whatever you want in this. He wrote the code that has a snake that just zooms about, eats pellets, and after 25 seconds, it will cancel the program and display the final result of how many pellets it ate. And then that will be displayed, it will read the humidity, and it will be a completely perfect program. So if you have any Python experience, feel free to add that in, but it's got to follow guidelines. Obviously, you're not going to run any shell commands or anything like that. Just display stuff on the screen, and it should be all good. There's also picture examples and other worksheets available online if you want to finish off with those. But just to keep it nice and simple, make sure nothing goes wrong, we'll just go for the bog standard kind of show message and the humidity sensor. So yeah, after my ramble, Charlie, would you like us to both work on the back color now?
On the background color, did you say? Yeah,
Lovely.
that sounds good.
Groovy. What I'll do, so I'll use a red example as well. So do you want to create a new show message, or do you want to create or add the background color to the existing show message that you have? Do you think the new one would be easier?
I think I want to add the background color to my message with the number.
Okay. So what we'll do is, just as before, we will add, so I have my message content, the text color, and the scroll speed. And then, once again, between the closing round bracket and the number, put your cursor right in the middle, hit comma, and once you've done that, you're ready to add the back color. Now, same principle with the text color, you put in RGB value, if I can speak. The RGB value will then be put as the background color. Anything like really bright it won't look too bright on the screen, but in real life, from personal experience, it is blindingly bright. So, like a fluorescent green or a nice magenta or pink will look lovely, and everyone will see it, probably from space as well. What we'll do though is add the comma, we'll do space, and we will do back underscore color equals, and I'll do red again, so I'll do 25 in square brackets 255 comma 0 comma 0, so 255 comma 0 comma 0, and as long as everything is lined up, that should be okay. Oh right, you know what I'll do as well, Charlie, do you have two messages on your screen, two show messages?
I've got two different ones, yeah.
Okay.
One with my number and one with hello world. Do you want me to change it to one?
I've got an idea. Why don't we put a comment at the start of the set on the second one to make sure we keep our time nice and short?
Okay.
So what I'll do is we can use something called comments in Python. Now, nothing scary. Essentially, it just removes code. It doesn't like delete it. It basically says to the program, ignore this line. Don't just go past it and execute the next incoming. Comments are very good if you want to document anything you're doing, and in large-scale programs, usually it's good practice to put comments. Comments are quite cool in larger-scale programs as well. But for this example, we'll comment our second one so that we make sure we're in the time frame. To do that, though, we'll put our cursor at the very start of the line that we want to comment, and simply put, we will put a hashtag in front of that message, and it should just go green. And I need to put it correct on Mac, and bingo, and now it's gone green. And whenever
Yep.
it's gone green, that means this code will not execute and is there just as text, really, that you can see that will not be executed and will just sit there. So when we run our code this time, oh, sorry. After make sure your back color is now set up with your scroll speed and your text color, what we can do is we can hit run. Oh, for me, it's gone red background, green text, scrolling across at very high speeds, and doesn't show my second message because that's commented out and the code won't run. It's also just left it red, so I think that it will linger the color so well. So you can make it go different colors if you wish. But yeah, how are you getting on, Charlie?
I'm changing around the colors to see what different combinations I can get,
Ooh,
but that's worked for me.
I will try that as well actually, because I want to see if I can make this really, 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 really bright. Let's go for a nice magenta as well. So use it at home as well. Tinker around. Like, those colors in the worksheet are not the only colors you can use. Once again, just as long as they're between 0 and 255, they should work. You can also Google different colors if you really want to, and Google is very good because it has its own little kind of slider bar that you can, a little gradient sort of map that you can just pick a color. It'll give you the red, green, blue value, and you can just drop it into your code. So, or if you like Google color picker, it should come up as well. But what I will do is I will type in.
We've got a purple here.
Da, 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 da. I will put a nice bright fluorescent blue. And is equal to that. Perfect. And I will change my text color. What do you think I should change my text color to? So I've got my background color to blue.
Maybe yellow?
Hello? So 25250. Perfect.
Yeah, like really, really bright, yeah.
Oh no. I'm shocked that AstroPis have been lasting this long. It is amazing. I don't think I get a phone to last this long either. If I run that code now, and oh, okay, I cannot read the text, but it is definitely going past. Charlie, you must know some color palettes because that is truly. Oh my gosh. Okay, no, I can't read that. Great. So, I think at this point, you've kind of got the hang of things. What I'll do as well, I think, is I will explain briefly how to print off the humidity. If you really want to, you can print off the humidity. There's also other ones. You can get the value of the temperature sensor. You can also get the pressure. And just as before, on the right-hand side of your little AstroPi Viz, you will see. Oh, by the way, Viz is the name of one of the AstroPis, just to let you know. On the right-hand side, like above the emulator, you have these little sliders that you can change the humidity, which is a little water droplet with the percentage sign in it, and the temperature and the pressure. But to print those values, what you do is you basically do. Actually, Charlie, would you be happy to do one of the examples now for the humidity? Like, guide you through that?
Yeah.
Groovy. I'm gonna. Come on, AstroPi, you've got this. Oh, it's spinning around. Okay, I can't stop that. Well, what I'll do is I'll print off the humidity at the end of my script, and I'll type in, just as before, sense.show underscore message. Just as before, just like a normal message, we'll put in sense.show underscore message, and we will say we want to show the value humidity, the value of the humidity variable that we had before. Now, if we put humidity straight in and you hit run, it's going to go, hold up, this is a float value. For those who don't know, a float is a floating number, which is basically not a whole number. And it will tell you that it's not compatible because it's a show message. You need to show a message, and they come in the format of a string. So we can turn that float number into a string. That's very easy to do, so it is, thankfully. What we can do is we can start off by typing the 3 letters STR. So str is abbreviated for string.
And where are we typing this?
Oh, we're typing this. Sorry. So you've got new sense.show_message.
Yeah.
Lovely. And then in between the round brackets, if you want to put in, as if you're putting contents like a piece of text, or like where you put the number before, just with no double quotes. So you want to put str.
Is that where I type in yeah. Okay.
Yep, that'll be perfect. And then once you've got str, that basically tells Python convert the following thing to a string. We will need to put in another set of round brackets. So add an opening bracket, and it should automatically close, and you should have 2 at the end and 2 at the start. And then basically, it will say, show the message, convert it to a string, and we want to convert the humidity value. So humidity, IDITY, and hopefully, all going well, if you have to type it correctly, you hit run.
I'm trying.
Ooh, I can't see my text, so it hasn't got any errors though. And I've got my humidity going, and then I'll change that as well, just for my next run.
Yeah, that's right.
That'll go successful on your end, Charlie.
Okay, mine's a big number. I set it up to 100%, so it's really big.
It is.
But yeah, that's right.
I forgot. There's a wee thing where it'll show 24% on your screen, but it's actually like a big long number after it because it's a continuous variable, so it doesn't really end. But the program will cut it off at some point and say, "Nah, we've got enough information here, enough detail as such in the sensor." So, what we'll do is you can just as before put in your text color, your speeds, everything like that. No issue at all. But we've messed around with AstroPy quite a lot, and we've built quite a good script that I think the astronauts will be very happy with. Now, what I'm going to guide you through now is very quickly how to submit your code. So you just have a little bit of time, and I can answer a few questions, or if you have any kind of queries on what you want to do. So Charlie, can I ask you to run your code and let me know if it goes successfully and has the 3 little ticks on below the code?
Yes. Okay. So it's showing up my 53 on the purple background, and now it's showing the humidity. So yeah, that's worked.
Lovely. And it is under 30 seconds?
Yes, it's 12 seconds.
Perfect. And mine is also actually 12 seconds. So, that's good. So, our entire program will run in space. Now, sorry, I need to run my code again to make sure there's no errors, just to make sure. Oh, because I put a space in it, it was updated code, so easily run again, and that should pop through. Now, this is the fun bit. For those who are wanting to submit their code to space, you must be 14 or under, or your entire team must be 14 or under. What we'll do is below the little checks that says read humidity from sensor, use ID matrix, and run your program without any errors. Below that, it'll say classroom code. This is very important you get correct because there's only one for the jam, and it will be the one that we can use for giving you the certificates. They should be coming out June time. But what we'll do is we will scroll down, and Charlie, do you see that box?
Yes, I've got it.
Okay. What I'm gonna do is I'm gonna tell you the very, very secret code to run and submit. Okay? So your classroom code is it's all lowercase, super, hyphen, secret, hyphen, code.
All right. Okay.
Okay.
Yeah.
That's found my name.
Yeah.
God,
so it says classroom code found teacher Samster.
Perfect. I'm not a teacher, by the way. I cannot teach, but that is successfully found it. And what you do is you click the big green arrow, and that will say, "Fantastic, we found your classroom." Put in your team name. This is the really cool bit. You can put anything you want. Well, maybe not anything, but put something cool into it. And the first name, and the age, and the gender, and essentially, whenever everything's all good, it will say, no, you can add more team members, obviously, below that, but if you're one person at home, no problem. Easily done. Whenever you put in your age, if you are 14 Charlie, by the way, you can feel free to fill that in. If you're 15 or above, it will say mark. It will give you the option to mark as an unofficial submission. Now, essentially because you can't run it on the International Space Station because it doesn't follow the guidelines. But you can check that box and hit submit, and it will all be good. And that's really it for the workshop. Essentially, if you want, take your time and you can work through your code. But whenever you're ready, submit your code, and it'll go through us. It'll give us an email to make sure it's all gone through. But we won't be able to check individually. It'll just say we've received some code, and whenever you're ready, submit team information, and we'll let you know how it goes in June. And then, if any issues, well, all going well, they'll all be in space. And if you are 14, if you're above 14, you'll get a wee certificate as well. Yeah. So that concludes this workshop. Hopefully you've enjoyed it and you've had some very fun ideas come from that, and many new ways to interact with astronauts from hundreds of miles away. I'm not very good with distances. I'm assuming it's at least hundreds of miles. But those is just kind of the wee things that you can do as well. There's also another competition that you can do, but that's for between, I can't remember what the beginning age is, but it's up to 19 years old, and you can do a space lab kind of mission. So one of them was where it was someone was able, or a team was able to make code that could detect whenever a space or an astronaut came into the same pod or capsule as the Sensat, because the humidity would have shot straight up because of the filtration and the very tightly controlled sort of environment. So AstroPi could say, yep, a spike in humidity, someone must be in here because we give off moisture. And little things like that, all sorts of little projects. There's also other wee programs you can do, but whenever you're ready, fire that through and submit it. But for now, what we're going to do is we're going to go to a break, and just to give you a little bit of time to finish up your code and get it all submitted. After that, we'll be back in 5 minutes, and we will be having the interview with Dave from the European Space Agency. So make sure you stick around, and happy coding.
And sampled the gases in the comet's atmosphere, especially water vapor, which was not quite the same as water on Earth. She had measured the gravity of the comet, the magnetic field in its surroundings, and how the comet interacts with the solar wind. During the 2 years, Rosetta had monitored how the comet changed as they moved closer to the sun and then away again. With all this information, scientists back home had learned many things about how comets formed and evolved. They also established that comets were made of the dusty and icy material left over after the planets were formed, and so they contain some of the oldest and best preserved material from the birth of our solar system. Rosetta had made even more remarkable discoveries. She found ingredients that were crucial for the origin of life on Earth. Perhaps comets had helped seed the Earth with these important ingredients when our planet was still very young. Scientists would definitely be busy analyzing Rosetta's findings for decades. Her mission had been a huge success. After a long search, she had even managed to find the strange place where Philae had ended up, fast asleep in a dark corner of the comet. But now, once again far from the sun, Rosetta was not generating as much power, and soon would not have enough to carry out her investigations. She could go back to sleep right away, but instead decided to undertake one last ambitious challenge. She was going to follow in Philae's footsteps and land on the comet. Rosetta was tired after 12.5 years traveling through space, but she was very excited about her last tasks. She would finally see up close some of the amazing sights she had been observing from a distance for the past 2 years. And she'd get to sample the comet's gases closer than she had ever dared to go before. It would not be easy, but the experts back home had everything figured out and the date was set. Rosetta would be targeting a really interesting place on the head of the comet. She wasn't going to be able to talk to Earth ever again once she was on the comet's surface. After all, she was never designed to land. So she would have to send back her last images and data as quickly as possible before saying her final goodbyes. Even though her incredible journey was nearly complete, she knew that just like the other comet explorers that had gone before her, the legacy of her amazing mission would live on forever. She felt lucky to have had so many friends and hoped they would still think about her and Philae from time to time. Finally, after 786 days at the comet, the last day of her extraordinary adventure had arrived.
We hope you enjoyed that short video. Now we'll hear from our special guest, Dave Hoeness. Dave is a didactics and technology expert contracted by ESA, which means he works with the education side of ESA and with all the astronauts that go to the International Space Station. We know Dave as the creator of AstroPi Mission Zero, which was the workshop that you just completed. But in the next 15 minutes, Dave and I will chat about experiments in zero gravity, who works at ESA or ESA, and are they all astronauts, and how you could land yourself a career that's out of this world.
So I'm Dave Hoeness, and I'm a didactics and technology expert contracted by ESA, and I'm working in the ESA education program. And what I do is my main job is to help coordinate the educational operations on board the International Space Station whenever there's an ESA astronaut flying to the ISS. So basically what I do is I work with the national space agencies from the astronauts' home countries to help coordinate their educational parts of each astronaut mission.
Yeah, you mentioned that each astronaut has a home space like association themselves. So if you just want to explain what the European Space Agency is and how that's how it like looks after all of the individual countries.
Yeah, sure. Okay, so obviously you'll have heard of you know, things like the UK Space Agency, and there's a French Space Agency, there's a German Space Agency, but the European Space Agency is this big intergovernmental organisation with 22 member states, and it's dedicated to the exclusively peaceful exploration of space. And so the idea is by coordinating the resources of all the 22 member states, you can achieve some kind of, you know, goals and missions which are beyond the scope of any one country.
And you've mentioned that you help astronauts make videos on the ISS of what they sort of do day to day. But a lot of students and a lot of the attendees of the JAM are really interested in what kind of science happens on the ISS. In the day of our workshops, they'll have done the Mission Zero AstroPi workshop, where they'll have been able to send some code to the ISS. So what other sort of science goes on up there?
So chiefly the main thing with the ISS is science where gravity is a variable in the experiment. Certainly. So you know, if you take any kind of scientific experiment and you remove gravity, strange things happens that we can then, study and learn from. And most of the experiments that are being done on the ISS have a gravity related kind of angle to them. So for example, things like studying virology, viruses grow much more virulently without gravity, bacteria as well. So you can actually sort of, with viruses especially, you can much more rapidly develop a vaccine because they grow so much faster, and you can work faster, if you see what I mean. And there's when Tim Peake flew to the space station, he had this really amazing experiment called the molten metal levitator or something it was called. I can't remember the exact name of it, but basically it was designed to form metal ball bearings, which will then form in microgravity and then cool back down. So you basically melt a small lump of metal in this kind of heater thing with a magnetic field holding the lump of metal, and it will form into a perfect sphere. Okay, and as it cools down, all of the molecules in the metal will all line up perfectly inside the sphere, if you see what I mean, creating this kind of insanely hard ball bearing, if you see what I mean, and that can then be used as, say, a part in a new type of engine, if you see what I mean. So there's lots of, like, material science, biological sciences, all kinds of different things that all involve gravity as a variable, and most of which is actually studying human behavior in microgravity. All of the astronauts act as like a guinea pig and they are studied themselves, each of them, in terms of how being in microgravity for 6 months affects their physiology. And one of the biggest things is bone loss, and muscle atrophy, because you're not loading your skeleton anymore. You're not using all your muscles, so their muscles waste away and their bones start to, and this is because the human body, right, has evolved in sort of like an environment on Earth where resources are scarce, and the body's super efficient at sort of processing all those resources. And the moment it thinks, oh, we don't need the skeleton anymore, we'll just get rid of that, if you see what I mean. And that's kind of like a biological side effect of how we've evolved. And if we want to go out further into space, these things need to be dealt with, if you see what I mean. And at the moment, all of the crew, they have to do about 2 or 3 hours of really hard exercise on the ISS to try and offset these effects, if you see what I mean. And there's a whole bunch of machines up there that allow them to create resistance using little vacuum tubes, and there's a bike which they can use to do some aerobic sort of respiration and stuff. And that's all to just try and so there's a lot of work being done just studying the astronauts' physiology. So yeah, it's mostly it's where you can create microgravity permanently, if you see what I mean. And that's it's the only way we've got to have a science laboratory where that is true.
Obviously, yes, the astronauts do a lot of work up in space, but there has to be a lot of scientists and engineers down on the ground that support them. What sort of work would people on the ground be doing to support people on the ISS?
There's so many. This is there's for every one astronaut, there's about 30,000 people contributing to that mission in some way or other. It's all kinds of different stuff. There's technical roles like people working in propulsion, people building launchers, navigation, all kinds of different areas of work, building all the launch vehicles. There's people working in the cargo resupply line, for example, all the Dragon cargo vehicles and the Cygnus cargo vehicles. There's so many people involved in just getting food and water and resupplies from the ground to the space station. And then there's all the medical stuff. So you've got the space doctors, dietitians, psychologists. Honestly, there's so many. And there will be always a greater need for good people than there will ever be supply, in my opinion, if you know what I mean. So the space industry is growing quite fast, always has been, usually a little bit higher than the rest of the economy in most countries. So it's always kind of hoovering up talent.
So what sort of careers are there in ESA, and are you all astronauts or?
No, we're not all astronauts, but there is actually an astronaut selection process happening at the moment, which might be an interesting thing for some of your some of your members to look at. If you go to esa.int/your way to space, you can, that'll take you to the information page for the astronaut selection. But that's you know, that obviously there are many other careers at ESA, not just in human spaceflight as well. So like you know, most of the things I've been talking about already are jobs related to human spaceflight, but there's lots of unmanned and robotic missions that ESA does as well, such as like Aeolus, which is a really big, like very, very expensive research satellite, which is looking at how wind behavior works on Earth. And it's got this huge instrument which uses lasers that reflect particles off of droplets of water being blown around in the atmosphere. And there's all kinds of roles involving like the scientific side of that. There's the you know, analyzing the data that science that payload is sending back. You know, there's Bepi Colombo, which is a Mercury exploration mission, which is you know, got a huge amount of people working on that as well. And there's 3 actual spacecraft in that, which when it actually arrives at Mercury, it's going to split into 3. And there's different teams of people all covering all the different aspects of each of those spacecraft. And then there's things like, well, quite famously Rosetta, and that mission's over now, but that had a lot of different people working on it. People, you know, just monitoring the instruments and doing all kinds of stuff with actually operating the payload, and people working out the navigation and what maneuvers it was going to be doing and things like that. So many different roles. Not just in terms of like a human spaceflight. There's obviously also education, which is where I work. But what it may be also useful for your members to know is that there is an ESA Young Graduate Trainee Program, which is basically paid internships at ESA, and for graduates. So it's usually people who have got a postgraduate degree. And that's a really good, a lot of people who are now very high up in ESA used to be YGTs. So it's like, you know, it opens a lot of doors for you if you've been a YGT, either in ESA or for other companies in the space industry. So that's another sort of good thing to look at.
And so far in your career at ESA, what's your favorite or coolest project that you've worked on?
Well, I think AstroPi is always going to have a special place in my heart, because that's the thing that kind of turned me into like a space person, if you see what I mean. And that's you know, and obviously I come from a software background, and you know, a lot of the software work that I did up until that point kind of prepared me for what happened with AstroPi, and being able to sort of teach young people about programming and knowing like what are the core concepts that people have to understand, and you know, and trying to build that into the educational program right from the beginning. So I think AstroPi is it's got a special significance for me. But anyway, so I'm working on this new project, which involves strengthening the teaching of radio communications. And radio communications is like fundamental to spaceflight. You know, all spacecraft you can boil down to 2 basic components these days, which is a computer and a radio.
Yeah,
if you know what I mean. And as ESA Education, we've already got some nice offerings with regarding to things like computer programming, like AstroPi, case in point. Basically, it's a set of classroom resources which take someone from knowing nothing about radio, going right through to being able to receive pictures from the International Space Station transmitted by radio. And there's a couple of little breadboard circuits that you do to first get the basic concepts. But in the end, what you end up doing is using one of these things, like an RTL SDR dongle,
yeah,
which you plug into USB port, and you can tune into a particular frequency and receive really nice pictures from the space station. And they don't transmit it constantly, so it only happens at a particular time. But the working group that I'm chairing at the moment, we made a really nice video which sort of explains all this. So if you go to youtube.com/ESA, that'll drop you into the ESA's channel page, if you see what I mean. Then if you click on playlists, one of the playlists will be called Getting Pics from the ISS. And then you can go on there, and there's a whole video that sort of explains the background. And then there's some technical videos which show how to do it on Windows, how to do it on OS X, how to do it on some mobile phones even, sort of thing. So it's quite a fun project. And you'll learn a bit about orbital mechanics, because the ISS is in low Earth orbit. You need to know when the ISS is coming over, how to predict when it will arrive, that kind of thing. So
obviously with your job you spend a lot of time thinking about the ISS and what's going on it. Given the opportunity, would you go yourself? Would you, if they said you can get trained up and go in the next few months, would you take the opportunity, or do you prefer your feet firmly on the ground?
To be honest, I would do it as a tourist, but I wouldn't do it as an astronaut, because the astronauts have like a very, very sort of high responsibility to each other and to the spacecraft and stuff like that. And I don't know if I've got the right kind of personality for that, if you know what I mean. It's a lot of I'd probably be very good with like the technical systems and things like that, and understanding the safety measures on the ISS and stuff like that. But you also have to be able to learn Russian, and you also have to speak it confidently. And I'm not gifted with languages by any means. And also there's there are some kind of like there's obviously the fitness aspect of it. They train you to within an inch of your life of your fitness, if you see what I mean. So I don't know if I could cope with that. And yeah, so it's I have a huge amount of respect for the astronauts and what they do. And there's also like some, there's the guinea pig aspect of it, which I'm not sure I would like either, where you're being poked and prodded and examined every 5 minutes, if you see what I mean. So they have to, there's also that side of it as well. The idea of going into space, though, is definitely something I would like to do. I'd like to see the Earth from space, because of this thing called the overview effect. And I think that it's something that I can only read about and only imagine, if you see what I mean. It's something that the first Apollo astronauts, when they came back, started talking about this whole kind of paradigm mental shift in their approach to everything after having seen the Earth from space. It's some of them had to have like counseling for it and stuff like that. And I've always wanted to experience that myself, if you know what I mean. And so I would definitely go up there as a tourist, but I don't think I am, if I'm being honest, astronaut material.
And then just to wrap it up, if one of our members of the audience, if a regular attendee of the Jam wanted to one day work in ESA, and have a software-ish job similar to yours, because obviously if they're here, they're going to be quite interested in programming and stuff, what steps would you recommend they take now, or what sort of things do you think they should try and find an interest in order to work in the space industry someday?
Mm-hmm. Well, I don't want anyone to think that you have to prepare from a young age to be able to work in the ESA space industry. And if you look at what happened with my career, I went off and was an archaeologist for like nearly 6 or 7 years, and then came back and did other things. And I took a very kind of like indirect route to get where I am, if you know what I mean. And I don't want people to be thinking that you have to get perfect grades and do everything right and be the most perfect straight A student in order to be able to get into the space industry, if you know what I mean. And that the space industry simply just needs people who are good at what they do and who work hard, and that's it, if you see what I mean. And if you find something that you enjoy it, that you're passionate about, and you try to be the best you can be at it, then you stand a very good chance.
Well, thank you for coming along today. We'll be having a live Q&A session with Dave after the end of the second workshop. So try and think of some questions that you've got for Dave now, and then you can maybe ask them to him later. But thanks for coming along, and thanks for telling us about your experiences with ESA.
Welcome back to our live stream, and we hope you enjoyed that pre-recorded interview with Dave. I certainly enjoyed chatting to him about space for, it was a lot longer than 15 minutes, so we're going to publish the full interview on our YouTube channel after this live stream. If you have any questions for Dave about space, or any questions about his job at ESA, or even about AstroPi, which is a project that he worked on for a long time before he worked at ESA, feel free to put them in the chat. They will be put into a list and given to Dave so that he can prepare an answer for them, and then we will ask him those questions in a live Q&A after this workshop is over. This workshop now is called Mission to Mars. It's our newest workshop. We only finished designing it a few days ago. But basically the idea is you're going to use code on your computer and then send a certain number of like commands to a web browser, which can then, or like a web server, which can then talk to bitbots that we have set up in the other room. If Vincent wants to show the bitbot table with some of the robots on it. You might be familiar with these bitbots. They just use a microbit, which we've used a lot at the Jam, and we use in a lot of all of our workshops, but we use them specifically in the bitbots so that we can draw and stuff. What we're using for this is called REPL. Hopefully some of the chat moderators will have put the REPL link into the chat. They'll have put the REPL link into the chat so that you can hear, or so that you can create an account and then you can get started with the first workshop. The first workshop is called Mission to Mars, Mars Lander. And hopefully that link has gone into the chat. Yeah, so I can see the link there. You don't have to sign up with an email address or anything. You just put in a nickname that you want to see displayed on your screen. And there should be loads of skeleton code that you are able to see, and then you're able to manipulate. This one's a bit easier than the last workshop. It requires a lot less typing. You're just changing one number at a time, really. And our stream people will be able to flick back and forth between the coding screen and the robot screen so that you can see what the bitbots are doing. I can also see the robots on my screen. I'm far away from the table, but I've got a live stream of the robots as well. And to help me with this workshop, we have Abby on the stream. Abby is one of our Jam volunteers who's volunteered with us for a long time, and I'm gonna show her how to use the bitbots through her computer. Through REPL, because I have a teacher account on it, I can see what her code is doing, and that means that we also have moderators that can see what your code is doing. So if you have any problems, you can just pop it in the chat, or there will be moderators jumping between each people's file to make sure that the code is working and that you're typing it okay. So if you want to introduce yourself, Abby.
I'm Abby. I've been with the Jam for a couple of years now, so you might have seen me, but I'm just, Lucy's going to be taking the reins on this one. She's going to be teaching me.
Cool. So hopefully I'm going to get started, but I'll go quite slow so that you can catch up to us. But me and Abby are going to go through the first few missions because it's Mission to Mars. And if the stream people can put the zoomed in robot view, it's for the story, Vincent. So the first part of the Mission to Mars is called Mars Lander. So that's the file that you should be in, and once you're in that file, you're ready to get started. So as you can see in that file, we've got some comments, and the comments say, "Welcome explorers, your Martian spacecraft is currently hurtling through space at 12,000 miles per hour, which was the speed that the Perseverance lander was able to go at in order to get to Mars in the past few months. It only landed a few days ago. To make sure that your spacecraft, which is the 4 bitbots, is on the right path to Mars, we need to be able to communicate with it. So our first mission objective of our mission to Mars is that we need to follow the instructions that we've laid out in the skeleton code to turn on one red LED. So red in RGB values, red, green, blue is fully red, and then no blue and no green. So you're going to set it to 25500. And you can do that on any of the 4 bitbots. And you'll be able to see it show up on the actual bitbots on the live stream. That's why we have the zoomed in view so that you can see the LEDs really clearly. Let me go back to my code screen. Okay, so I can see Abby's code, which we can flick back and forth between. So in order to so the mission objective is set one LED to red on any of the 4 bitbots, and the bitbots are numbered 0 to 3. So there's 0, 1, 2, and 3. And in the code in REPL, I have a little diagram or a little note that says that the red bitbot with the red square on it is number 0, the blue one is number 1, the green one is number 2, and the yellow one's number 3. So you can pick whichever one you want, but then you also have to pick, so then you type that into where spacecraft number is. So Abby, which Martian rover are you going to pick to change the colours on?
I think I'm going to go for 2.
So the
2
green
seems like
one?
a good number.
Yep, so you're looking for the green one?
Yeah.
And then each of our Martian rovers has 12 LEDs on it. Yeah, someone's nodding at me. They have 12 LEDs on them, which are numbered 0 to 11. So there isn't a number 12, but there are 12 in total. So you can pick any number between 0 and 11, and don't all pick 0 and don't all pick 1, because I want to see loads of red lights. So which one are you going to pick, Abby?
I'll go for 11.
11, yep. So that's the...
What about if I went for 13? What would happen?
If you go for 13, you can try running that code now. So if you click the big run button at the top, you can see it says, the error says LED number 13 is not between 0 and 11. So we have put in some error checking to make sure that you're aiming for the right range of numbers. Yeah, so you fix that there to 11, perfect. And then, as I explained in RGB, you need to set the R value, which is the red, to its full brightness, which is 255. So Abby, if you want to change red to 255. Yep, and then green and blue just stay as 0. And that's the first mission objective finished. You should be able to run that now and look at the live stream. Obviously, Abby can look at the robots in real time, but I can also look at my live stream. Oh, they've killed it. Where's my live stream?
Yeah, I can see my LED.
Oh, look, there's loads of them on red. Sorry, there was a slight delay. We also have an overlay. So some of our Jam volunteers are really interested in live streaming and stuff. So we have an overlay which can show you on the different rovers which lights are lit up. And then later on, we'll get to the point where you'll be able to see who did that work. But right now, all you can see is which lights are lit up. I can see some of you are going off spec and changing the colours to colours that I haven't asked for. But that's mission objective 2. So if we're treating this as a Mars lander, if we're treating this as a spacecraft on its way to Mars, we don't want to just be able to send one message. We want to be able to send lots of messages and lots of different messages. So if we scroll down to mission objective 2, we want to change the code above. So we want to use the same code that's in the top part of the screen. And we want to change it to have a completely different color, but you can use the same light and the same rover. You can choose different ones, but it's really important to change the color. So we're going to scroll back up to where that code is, where it says red, green and blue. And Abby, you can either just change these to random numbers and hit play or hit run, or you can look up an RGB color picker, pick the color and then read off the RGB value that you want to have as your LED color.
I think I'll go for the RGB picker and pick a nice fun color.
Yeah, I'm just looking up one here. So there's a nice one, if you type it directly into Google Chrome, there's a nice one pops up immediately. You don't have to go to a website. And you can change the hue and saturation as well as the actual pigment of the color. And then at the bottom, you'll see the 3 numbers. RGB will always be red first, then green, then blue. And you can just copy those numbers directly into your code file and split them up, obviously, into their correct places. Oh, yeah, I can see you've done that. Oh, and I can see
Lucy,
an error.
I've got an error here saying that the blue 256 is not between 0 and 255.
Yeah, so LEDs can only have their color between 0 and 255 because it's to do with binary and base 8 or base 2 and having 8-bit storage of numbers. So 255 sometimes seems like a weird number to just have as a limit. You might think it should be between 0 and 100 or 0 and 1000. But 255 is there for a very specific reason, and it's also the same reason that we always start counting at 0. But yeah, if you put in 255, 255 should be within the limits. And 173. Yeah, and I can see that running again. And do you want to flick back to the robot screen so the audience can see all of their lights popping up? I can see a few green ones and a few blue ones. Oh, and I can see a black one, which is obviously someone set it all to 0, but that won't show up. Oh, I can see loads of green ones. Yeah, that looks really good. Here's a challenge to see if anyone can make it yellow. I think Sam did yellow in the last activity, but yellow is quite a difficult colour to make using RGB. I always mess it up. So how would you make yellow? Because yellow is a primary colour, so you can't really mix colours to get to that. I bet Abby looked it up. I can't see Abby's screen, but I bet she looked it up.
Anna, I'm just putting in random numbers to see if this will make yellow. I have no clue.
And you're looking at spacecraft number 2, which is the green one, and you're looking at LED number 11, which will be one of the very edge ones. And if I can look at my live stream. Oh, that was cool. It did like a lens flare.
I think someone's got a yellow.
Oh, yeah, I can see a yellow one on rover 2, on the green rover. I can see a yellow one. That's nice and bright. You did look it up. I can see you on the live stream. So that's great. Now that we know how to send one piece of information and we know how to change that one piece of information that we send, we're going to move on to mission objective 3. If we were actually communicating with something that's in space, we don't want to do it one piece of information at a time. So if we're sending it directions, or if we're sending it like telemetry data, we don't want to be sending it, we don't want to be typing it and sending it one piece at a time. So we want to be able to automate the ability to sort of go through data and send it one bit at a time. And I'm going to show this very briefly with a for loop. So if you scroll right down to the bottom, you can see it says mission objective 3, follow the instructions below to use a for loop so that you can program more than one LED every time you run your code. There is a for loop at the bottom, but I've commented it out so that it hasn't been running yet because I needed that skeleton code to be there, but I didn't want it to be running yet. So, oh, that light's just gone off. Can you see where my mouse is, Abby? Yeah. So you want to delete those 3 speech marks at the top and the 3 at the bottom as well. And then also delete this line of code, this line of text that says remove the speech marks from this code. Just remove that whole line.
What would happen if I kept that line in?
You would get a runtime error because normal written English doesn't fit the syntax, so it doesn't fit the structure of Python programming. So while a lot of Python looks like normal written English, this IDE, this integrated development environment, can't understand exactly what you're saying. But that's why we use comments to try to tell the compiler to ignore this line. This is for humans to read. This isn't for you to read. So if you had run that, it would have just given you a big Python error. Your console would have just been filled with red stuff to say, nope, you did it wrong. Go back, try again. So yeah, now we've got our for loop. It's gone all colorful, which means that the code has all been, it's being looked at as we're looking at it. Or the IDE is looking at it in the same way that it has been the rest of the code. And you can see that it starts off with for I in range 0 to 11. So 0 to 11 are our LED values. And then we're going to set the LED number, which is a variable that we've been using at the top the entire time. We're going to set LED number to I, which means that it's going to cycle through and it's going to change the LED number from 0 up to 11 through each passing. So every time it goes round, it's going to have a new value for the LED number. And for each value of the LED number, it's going to run the same print request. The bit down here is just, this is what we've been using the whole time. It's just a URL that basically sends it to our server. You don't really need to know how it works, but you can read it and understand where it's asking the question, where it's sending the command. And then a very important line right at the end that I've got highlighted there. Can you see that, Abby?
Yeah.
Yeah, it says time.sleep.
Right at the end.
And that's because so that you can't send too many messages at once, we need to have a sleep, we need to have a break, or in some other languages it's called a wait, in between each of your messages being sent. So this is going to send 12 messages in total, but you can only send one per second so that you can't send too many, which is why we've got time.sleep, and the 1 is in seconds. So if you want to also change all these numbers, so your spacecraft number and then your different colors, whatever you change these colors to, the red, green and blue that are currently set to 0, whatever you change that to, all of the LEDs on that rover will be changed. But we don't know what happens when lots of people do it together. So they could battle each other the same way the Christmas tree does. So if you were here last month, you saw that the Christmas tree, as someone's lights were going up, someone else's lights would follow them and erase them. Oh, I can see that you've hit go. I'm going to try and look at my... Yeah, I can see something lighting up one at a time. Yep. If you want to flip back to the robot screen so that they can see all the lights coming on. You're all setting the brightness up very high. You can use lower numbers between, so if you use numbers that are around 100 for each of the 3 values, you get much dimmer lights, which are easy. It's easier to see the colors whenever we live stream it. Yeah, so you've got it with a little bit of red and lots of blue, so that's going to set them all to purple. And you can see that it works really well. It goes through each of your LEDs one at a time. Someone has asked in the chat, what does the secret mean? They've seen that it says header equals secret, and then I've written in type of secret code. You can change this, so this is going to be important in the next exercise that we move on to. Where it says type of secret code, I want you to put in anything, just 3 random words or your first name or anything that you want it to be, because that's not going to show up on the live stream or anything. That's just so that the server knows who's sending the same request. And then we have a thing on our end which is going to assign you a random name, and you can see your name. So Abby's name is Dazzling Varia or something. It just generates a random name. It's just a bunch of random words. But it means that whenever we do the next part, which is we're going to move your Martian rover, you'll be able to see where you've sent which robot you sent the command to and when it's running your command. Someone else has asked me, what is the F in the string? What does that mean? I think it means format. Andrew's telling me it does mean format. It's a way of sending URL requests, basically. So we're requesting a server that we have here, or like in the cloud, which isn't anywhere. And it's basically taking in the spacecraft number, the LED, all that information in order to send it then to the bitbots. If you want to know more, ask Andrew, because he built it and I don't know. I just drew the Martian map. So I've been told that the F string allows us to embed variables inside a string, which obviously is where the format comes from, because you're changing the format of the string. You learn something new every day. So the next thing we're going to do, I would say you've successfully completed mission objective 3. You've changed the lights several times, Abby. You've changed them to lots of different colours. What you can do, if you have spare time, if what you want to do is change the sleep time, you can make it anything greater than 1 and it'll increment your LEDs slower. But you can't make it less than 1 because it'll give you an error. So if you want to make it less than 1, you can see what the error is. Yeah, so you put in 0.5, and then if we run that, it'll run 2 of them, and then it'll give you a bunch of errors. I'm just going to click stop on yours. It'll give you a bunch of errors that say, too many requests, you sent too many requests, you're only allowed 1 command a second. And that's why we put in the sleep function, and that's why we imported sleep at the top of this file. Or we imported time at the top of this file, sorry. So that's us finished with our Mars lander. So now that we've landed on Mars, or we've gone through the solar system, we've gone through all of the space that we have to get to Mars, we're about to land on it. So if we want to go back out, so Abby's going to show you how we go back out of this individual.
Can I hit the little robot guy?
Say again?
I was just saying that you hit the grey circle with the robot on it to get out of it.
Yeah. and then you should be able to go into, I should have opened up now, Mission to Mars, Mars Rover. You should be able to see that as your other
Yep.
file in there. Yeah, so if you want to go into Mars Rover, and then I'll join you in your coding environment, because if I go into it, I can't see what you're doing. But yeah, I can, now that I've exited out of it, I can see loads of people. Yeah, Abby's in Mars Rover, so I can click into that. Yeah, Abby at the jam. Cool. So hopefully you can all see that on your screen. She's in a different coding environment now. It looks the same, but it has different skeleton code. That's because now we're going to move on to, instead of having just Mars landers, we're going to have Mars rovers. So you can maybe see on the, if they zoom out on the robot map, whenever you see the zoomed out robot map, we've marked onto our map loads of different places where different Martian spacecraft have landed. So there's Pathfinder and Sojourner, and the newest one, which is Perseverance, and then we've got all the Mars missions, which were the Russian ones, and we've got the UK mission, which crashed, and we've got the ESA missions and stuff. Oh yeah, so you can see Opportunity, Beagle 2, Perseverance, all them. And then, so if everyone's in the second coding environment, you can see that the comment at the top, this is a multi-line Python comment, by the way. That's what they were asking for in the last workshop. You do 3 speech marks. It says, "Congratulations, Explorer. Your Martian spacecraft has safely landed on the surface of Mars. Your Martian spacecraft is a rover, meaning it can move around and explore different areas of the Martian landscape. And that your 4th mission objective, so mission objective 4, each of the 4 Martian rovers has its own landing site. So some of our helpers will hopefully move. Yeah, so they've all been moved to their landing sites, and they've all got a pen. I can see the red rover has a red pen, which might start messing up with our map. You're going to change the Martian landscape forever. Each of the 4 Martian rovers has its own landing site and destination, and you guys all need to work together in order to, so you need to work with your other Martian explorers to get the coloured rovers to their coloured X marks the spot. Let me see on the map. Yep, so you can see blue is at the top left, green is at the top right, red is at the bottom left, and yellow is the bottom right. And you can all send one command each for like a period of seconds. So it's the same with the LEDs. You can overwrite each other's commands, or it might stay there for a lot longer depending on what you do. And you just need to work together to try and go through the Martian landscape and end up at that coloured X. So Abby and I are going to show you how you can start the rover moving. We're quite nervous about this because we haven't done it with lots of people yet. We've done them one at a time. So Abby, you have to pick a rover between 0 and 3 again. So you can pick any rover.
I think I'll go for 3 this time.
Yeah, I think 3 is, I can't remember which colour 3 is, but you'll find out when it moves in a minute. And then the way that the motors work is you're setting their percentage of speed. So you're setting it between 0 and 100%. But even though percentages don't go into the negatives, you can also do up to negative 100, because that means it'll spin backwards. So if I wanted to get you to spin on the spot, Abby, and I wanted 1 wheel to go forward and 1 wheel to go backwards, what would you do? Yeah,
Would I do this?
Yeah.
Or would that be too much?
It might be too fast. We'll maybe try it with 50 to start with. Just because we'll have to figure out.
Do I have to put the percentage in it?
No, you just put the number in, and then it works out that it's a percentage. And then you can see the request at the bottom, which is the same. And if I go into here, is anything moving?
I think red just moved.
Normally it moves for a really... Normally it doesn't stop moving. Let's run that one again. while you're doing this, if you still have the code open from the other, just for the people at home, if you still have the code open for the other REPL worksheet, you can keep changing the colours of the LEDs whilst you're working away with this. I can't see anything moving yet.
No, me either.
Maybe it's the negatives.
I just switched my
Is it
robot to see.
I can see peripherally yellow is off its spot, but I don't know if that was just because it wasn't put on its spot. Oh, bad gateway. Interesting. Andrew's fixing something, isn't he? Yeah. So it wouldn't be a jam if we didn't have technical issues and if we didn't try something totally outlandish. But I promise we definitely have 20 minutes of this workshop left, and we'll definitely have something moving by the end of it. But for the minute, I can see someone pointing at the red robot. Oh, it's moving.
Oh.
Okay.
Is the green one number 1? Oh, the red one keeps getting stuck.
Oh, okay. The red one's caught on the paper. Cool. Okay, we've got it going. I wonder what happened
things
there.
moving.
The red one's doing circles.
Yeah.
Okay, yeah, so you're changing your code again so that you can make it spin, which means that the left motor will go forwards and the right motor will go backwards. And that would be a useful maneuver if you actually were on Mars, to be able to turn yourself on the spot instead of having to do a big sweeping arc. Yeah, and you've run it again. Have we figured out which one you're talking to? So you're talking to number 1.
Yeah.
I can see lots of hands in the robot table frantically sticking things back together.
Yeah.
What you can also do is make one motor move a lot forward and one motor move a little bit forward, and they'll be able to create that big sweeping arc, which is more useful if you're trying to get to a destination. So from this point, the blue rover is probably wanting to, I think it's number 1. It's having a little bit of a panic attack, doesn't know which one it is. The blue one, for example, would want to do a big sweeping arc to the left, which means that it would want its right motor to be moving faster than its left motor. I think we might be making some more movements. Has anything else moved?
Red is moving right now.
Yeah.
Little bit by
very
little
slowly
bit.
into the wall.
So if I were to make this 40 instead, would that give it an arc?
It would give it an arc to the right, yes, because the left motor would be moving faster than the right. The team have told me that we're currently having a few technical issues, but they are being resolved. They are figuring out what it is. Could it be because so many people are sending requests? Yeah. So this is obviously the first time that we've run it with a high volume of people sending requests all at once. Beforehand, when we were testing it, it was just like me and Andrew talking to one robot each. What we can also do, I think... Okay, I was going to say we could add more robots, but we might do it at the end. But it would give them more opportunities to not conflict the... Okay, Andrew doesn't want to do that. So far we've got 4, but we could have 10.
Chaos.
I would say you've successfully completed mission objective 4. Well, you've got it moving. You haven't got it to its destination, but you've got it moving. And then mission objective 5 is to combine all of your new spacecraft management skills. So imagine you're an engineer at ESA or at NASA, and your job is to drive the new Perseverance rover, for example, or if your job was to drive the Curiosity rover. That requires a lot of skills, and it requires a lot you being able to use those skills all at once. So if you were able to both send messages that move the motors, as well as that change the LEDs. That would be like you're sending and receiving signals whilst you're moving about. Is Abby still there? I can hear someone else.
Yeah, I'm still here. Yeah, no, I think it's Andrew.
Now we've got
He's
nobody
nodding,
moving.
so I think
When
that was it.
when did the yellow and the green one switch?
Yeah. A robot has been stolen.
Someone in the chat has asked, what do the motor numbers mean? The motor numbers are it's the percentage of the maximum speed of that motor. So if you typed in 100, it would be the full speed that motor can move, and if you typed in 5, it would be 5% of that motor speed. 50 is like half of its full maximum speed. What are the range of numbers that we can use? For the motors, it's minus 100 to plus 100, because minus 100, this is a vectors thing, so minus 100 is 100 in the direction that isn't the positive direction. So basically, if you take forward as positive, then backwards will be negative, and that's a vectors thing, because vectors have to have a magnitude and a direction. We still don't have anyone moving, but I can see that these are still turning on and off the lights, which is good. And someone is moving my stream so that I can't see it anymore. But yeah, it's just an LED specific thing is why we use 0 to 255, and then for this it's more to do with speed. Oh, the red
One
one's
of them's moving.
What number is the red one? 1? Let's see if we can program it. So yeah, we've got robot number 1, left motor 50, right motor 40. If you want to run that code, or if you want me to run it, you can click it.
They're inching.
And then we can hopefully see it turning. Oh, you did one movement. The robot doesn't want to move anymore.
Yeah.
Fortunately for us, these are only bitbots. But imagine if you had sent a rover the whole way to Mars and then realised that it wasn't working. That was the case for the Beagle 2 lander, which was one of the first UK Space Agency landers that went to Mars. And it landed properly. It landed as it was meant to. And then it stopped communicating after like 104 seconds, which is under 2 minutes. So it was able to send, it was able to send 70 scan lines of a photograph before it couldn't be communicated with anymore. But at least these are only bitbots, and we haven't spent like entire careers working on these things. That's why it's so impressive whenever a team is able to land something on Mars or on any planet. We're just using Mars as our example today. But whenever a team is able to land anything on a different planet and is able to maintain communication with it without being able to go and physically like look after it and fix bits and replace bits and stuff, it means that it's been built really well and it's been programmed really well. And the example of, I think, Curiosity or Opportunity, whichever the last one was, I always forget, it lasted for over 15 years, which was like well past the amount of time that they expected it to last. But you can see on our map we've got loads of different landing sites, and we tried to make them as accurate as we could. I can see someone asked in the...
What has the...
Say again, Abby?
What has been the most recent landing? What's been the most recent landing?
So the most recent one was Perseverance, which is over to the right hand side of the map next to the yellow bitbot. It landed, I think, 2 or 3 days ago. I can't remember what day it is. And it's a NASA lander. So Perseverance is the... I've got an echo. Go away. Perseverance is the rover. And then with that rover, the whole mission I think was called Perseverance. So Perseverance was the rover, and then there's also like a small drone helicopter thing on it called Ingenuity. NASA like to use words like that, so they've used opportunity and curiosity and ingenuity and spirit is a good example as well. Words that mean like we're going out into the solar system, we're looking for stuff, and we're trying to go out and explore. Whereas the Russian missions are literally called like Mars 1, Mars 2, Mars 3. Have we got any more movement with them?
Not that I can see.
I don't think we've got any more movement
I
with
think
them.
they're working on one at the minute.
I can't see the blue one.
Yeah, I think they've taken one off the test.
Yeah, they must be working on the blue one.
Yeah, I think they've taken the blue one off the test.
I can see someone asked a question, does the secret header need to be set to something specific? No, it just needs to be set to anything at all. So I've just set it to a placeholder. But that basically means that whenever you send your commands, you're able to receive the same name back. So if you took that out, every time you sent a command, you would get a randomized name back, and you wouldn't know where your command had been, or it would be difficult to tie it up. Normally, whenever this is running well, you're able to see who has sent the command to each rover and what the motor command was. So it could just be set to anything. We do have some movement with the red robot. Yeah, I saw it do a turn.
Oh, the green is doing circles.
Yeah. Someone has moved
green
my
is
stream
having
view.
a right old time.
Someone has moved my stream view, so I can't quite see that, but I can see the paper bubbling up in the corner. Oh, it's stuck against the wall. Abby, do you wanna try and send another command to the red one, because we know that that's robot number 1, because I can see the lights on it. Wait, it's disappeared. Someone's picked it up.
I think the red one. I think the red one's now off for testing.
They've just picked up the red one. Pick a different one. Pick any other number. 0, 2, or 3.
I'll go for 2. I think it's just being a bit temperamental. It's choosing whether or not it wants to or not.
Yeah. What number is the blue one? Because it's the most recent one that's been popped down.
I don't know. What number is the blue one?
It has it on the
I think it's
microbit
0.
matrix. Okay. Well, if we try popping in 0, we might be able to move the blue one, because that was the one that they had in their hand fixing it. Nope, the red
one has been
though.
returned.
The red one has some lights on it as well.
Oh, wow.
Someone has turned on some pink lights on the red one, I think.
Okay, so I think the blue one is 0 and the red one is 2.
Yeah.
The yellow one is 4 and the green one is 3. Oh, 1, sorry. Wait, no, the yellow one is 3. The green one is 1.
I think we'll try. Oh, I can see red doing circles.
The red one's doing circles.
Yeah. Oh, I think it's because it's the way it's stuck. Oh, nice. Okay. See, that's a proper movement. That's what we were aiming for. That's what we were hoping everyone would be able to do. And then ideally, someone else would butt in with a new command to make it go in a different direction. I'm now just watching the live stream that I've got, the live stream instead of the delayed one, to see if any of them are moving. Obviously, the next part of this code that you would do is you would program it so that you could set a speed for a certain amount of time. So all that we've done, we assumed that the commands would overlap a lot. So it would maybe move in one direction for a few seconds and then move in a different direction for a few seconds, or it would time out after 2 or 3 seconds. But what you could then do is set each speed for only a certain amount of time. So you could do that with the import time thing that we did in the last one, or you could do it for you could try and do it for like an amount of distance if you were trying to do something like a turtle with a bitbot, which has been done before. But because of the way that we're feeding this from the internet to the microbit, you can't really do it in the same way that you would normally do it with bitbots, which you can set like a certain amount to roll forwards. I think a lot of people are sending in commands all at once, and it's maybe not happy trying to execute them all at once.
Yeah.
I don't think we've got any more movement out of any of the rest of them. But the red one looked like
No,
it was
I
having
think
fun.
Red has been persevering. Yeah.
Aha! No one else heard that yet. They'll hear in a second. Yeah, so you can see lots of pink circles in the bottom left corner because that's where red has obviously been working away. Oh, we've got that error again, the bad gateway error, even though we didn't send anything.
Yeah.
Thought I was about to get a message.
Dunno.
So.
Oh, the green ones are moving in circles. Is that the one I sent? What number am I? I'm 1. I think I might have said that.
I can see lots of lights on still. It's a good thing the lights were working. But yeah, I can see the green one doing circles
Yeah.
now. That's pretty out. It's
A lot of circles.
It's basically on the curiosity space. I think it's maybe the wheels. So maybe people
Yeah.
are sending straightforward commands and the wheels are sticking, so that's why it's going in circles. But yeah, I'd hope that
Yeah.
whenever Curiosity landed, I hope it did a bit more than just drive around in circles for a few seconds. I keep seeing that error.
Still getting a
the
wee bad gateway error. Yeah.
All of your
I am sending it to 1.
all of your things are within
Try a different one.
the defined limits. No, we keep getting that bad gateway. I'm sure a lot of people at home are also getting a bad gateway error, but I can see the blue ones reversing
Yeah.
in circles now.
Oh, the blue one's away now.
Someone keeps picking them up. Still cramping their vibe. They're just trying to do circles. No, I think it's done killing. I can see you picking it up. Trying to make it reset.
I think they're trying to make it go straight.
Yeah.
Get to their wee marker.
It worked really cool whenever it was just one person doing commands.
Yeah.
It could mean that we just have to work on timing out the commands that are sent, and we have to like limit each person to a few seconds that they get to control the rover. But it was great being able to test it, at least with all of you watching and all of you taking part. I think we're gonna wrap up.
Yeah.
Oh, hold on. The team are telling me that it looks like
Oh, the
someone's
red one's
DDoSing
moving
us,
now.
which basically means that someone's spamming a huge amount of traffic at our server. DDoS means dedicated denial of service. So if you send a lot of information to a server, it's unable to pick out which information that it actually wants, and it's unable to take any more information. That's what DDoS means. You'll hear that in a lot of sort of internet contexts. Yeah, what did I say? Oh, I said dedicated. Yeah, distributed. Dedicated and distributed are the same.
The red one's doing some fun circles. Got a nice pink circle going on.
Yeah, a nice thick one. I think we'll wrap up with this workshop for today, but it was good fun. It was good fun while we were able to change the LEDs. I do have an echo in my ear because Kaelin has walked into the room. It was good fun while we were able to change the LEDs. You can imagine that you would be really gutted if you got to Mars and that your rover didn't work. But hopefully we'll be able to fix some server issues. That's why there's been so many rover launches and not that many completely successful missions that are as successful as Curiosity and Opportunity have been recently, or as successful as Perseverance will be, because it's definitely going to be a roaring success after that landing. I think we're now going... Oh, hold on, someone's sending me a message. Yeah, we're going to a break for 3 minutes. So if you want to go grab a drink, or if you want to just have a break from looking at your screen, and then we're going to get onto a live Q&A session with Dave, who was the person that I interviewed earlier on, and that we've been talking about, and he was the one that created Mission Zero. So make sure if you have any questions for Dave, put them into the chat, and we'll be able to put them together into a list, and I'll be able to ask them to him, or Sam will be able to ask. But thank you. We'll see you after the break.
Bye.
Rosetta had spent over 2 years at Comet 67P Churyumov-Gerasimenko, but her time there was already coming to an end. She had made millions of measurements, and by now knew the comet inside out. She had taken photos from all angles, collected dust grains, and sampled the gases in the comet's atmosphere, especially water vapor, which was not quite the same as water on Earth. She had measured the gravity of the comet, the magnetic field in its surroundings, and how the comet interacts with the solar wind. During the 2 years, Rosetta had monitored how the comet changed as they moved closer to the sun and then away again. With all this information, scientists back home had learned many things about how comets formed and evolved. They also established that comets were made of the dusty and icy material left over after the planets were formed, and so they contain some of the oldest and best preserved material from the birth of our solar system. Rosetta had made even more remarkable discoveries. She found ingredients that were crucial for the origin of life on Earth. Perhaps comets had helped seed the Earth with these important ingredients when our planet was still very young. Scientists would definitely be busy analyzing Rosetta's findings for decades. Her mission had been a huge success. After a long search, she had even managed to find the strange place where Philae had ended up, fast asleep in a dark corner of the comet. But now, once again far from the sun, Rosetta was not generating as much power, and soon would not have enough to carry out her investigations. She could go back to sleep right away, but instead decided to undertake one last ambitious challenge. She was going to follow in Philae's footsteps and land on the comet. Rosetta was tired after 12.5 years traveling through space, but she was very excited about her last tasks. She would finally see up close some of the amazing sights she had been observing from a distance for the past 2 years. And she'd get to sample the comet's gases closer than she had ever dared to go before. It would not be easy, but the experts back home had everything figured out, and the date was set. Rosetta would be targeting a really interesting place on the head of the comet. She wasn't going to be able to talk to Earth ever again once she was on the comet's surface. After all, she was never designed to land. So she would have to send back her last images and data as quickly as possible before saying her final goodbyes. Even though her incredible journey was nearly complete, she knew that just like the other comet explorers that had gone before her, the legacy of her amazing mission would live on forever. She felt lucky to have had so many friends and hoped they would still think about her and Philae from time to time. Finally, after 786 days at the comet, the last day of her extraordinary adventure had arrived.
Hiya and welcome back to our stream. We have Dave Hoeness live now with us, and we're going to ask him a few of your questions that you've been putting in the chat. So the first question is from Tom, who is 7 and has obviously been helped with an adult. Wants to ask Dave, why do some planets have no atmosphere?
I don't think Dave can actually be heard. Yeah, Dave has no sign right now. Give us a second. Can we talk? Tell him for a second. Tell him that we can't.
Sorry, Dave, I don't think the team can hear you. What? I can't hear you whenever he's talking because it's noise cancelling. What are you saying to me? Okay, they're now telling me to wait.
Yeah, give us a few seconds.
I don't think so. I think that's the issue. I think they can't hear either of us. Yeah, so they can see us, but they can't hear us. Yeah.
I know.
Can you hear us yet? Can't hear either of us?
No, we can hear. We can only hear you right now. We can't hear Dave.
Oh, okay. They can't hear you, just they can hear me. I can hear you because, yeah, I'm on a call. It should have gone through this call, though, your audio. That's what worked earlier. I think they can hear me is the thing. I'm not sure.
Yes, they can hear you.
Okay, no one has told me that yet. So we're having audio issues on the live stream with the call in from Dave. And that's what the team's currently trying to fix. And in a minute they'll tell me once they've fixed it, and then I can continue asking questions. And it's also really hard to read any facial expressions because everyone in this building has a mask on. They keep trying to mouth things at me and I have no idea what they're talking about. I think Vincent's looking through some settings now. Are you getting audio from Dave?
No, we can only get audio from you right now, but it's an OBS.
I can hear him is the thing, so yeah, but it's not as if this is a call this is a call through OBS, so
Can Dave say something?
Dave, do you want to test your audio again? Can't hear it? No.
It's our end.
It's definitely Vincent said it's definitely his end. It's definitely the jam end.
Vincent. Can you put Dave's audio on your speakers and let's pick up the next?
Yep. So what I'm now being asked to do, I'm going to disconnect these Bluetooth headphones and then feed it out through the speaker. And then turn up. Do you want to test your audio again?
1 2 1 2.
Yep. Dave,
1, 2,
are you
3, 4,
able to
5,
hear
6,
me?
7, 8, 9, 10.
Are you able to hear me?
Yeah, I can still hear you.
Okay. That's fine.
You're much quieter now.
Okay, I'll try and speak up a bit. So our first question, hopefully you're able to hear both of us. Our first question is from Tom, and he wants to ask Dave, why do some planets have no atmosphere? And Dave was part of the way through this answer, but we'll start the answer again so that everyone can hear it.
Okay. So yeah, it's a great question. It's basically to do with the size of the planet and where it is in its solar system. So a planet that's close to its sun will have its atmosphere heated up by the the solar radiation coming from the planet from the sun. Sorry, and that makes the molecules in the atmosphere fly around much faster, and they have more energy, and they can actually achieve escape velocity and fly off into space. And also the pressure of the solar wind can actually shear like particles off the atmosphere as well, depending on how close the planet is to the star. Larger planets have more gravity, and therefore they're able to sort of retain their original atmosphere from when they originally formed, when the sort of solar disk of matter as the actual solar systems is forming and the planets are condensing into solid objects. Some planets will form without any atmosphere, and some people think that the Earth and Venus and Mars actually originally formed with no atmosphere and then outgassed over a period of time, which then formed their atmospheres, if you see what I mean. And Venus, for example, has had a runaway greenhouse effect, and all of the carbon dioxide on that planet has basically been sort of ejected into the atmosphere, which is the reason why it's so hot. It also has a very long day. The day on Venus is about almost the same as its year. You see what I mean? So volcanic activity and things like that on Earth probably also ejected a lot of atmosphere into the air over time after the Earth formed. And Mars is really interesting as well because if you look at a topology map of Mars, you'll see that like the northern hemisphere of Mars is mostly flat and smooth, and the southern hemisphere of it is mostly kind of rocky and got lots of craters on it and stuff like that. And some people theorize that Mars received a huge catastrophic sort of asteroid or comet impact at some point in its history, which may have caused a huge eruption to eject most of the atmosphere out into space, and that affected the core of the planet quite a lot. And the actual the core of the planet is responsible for the magnetic field. And if you look at the magnetic field of Mars today, it's fairly okay on the southern hemisphere, and it's almost like not really there. It's quite ephemeral on the northern part of the hemisphere.
Because it's so flat, yeah.
That the magnetic field actually protects the planet from the solar radiation. So what's actually happening on Mars today is that on the northern hemisphere, where the magnetic field is weak, the solar radiation from the sun is shearing off atmospheric particles into space, and it's been constantly sort of losing atmosphere through that process. But Mars is also outgassing as well, so it's also slowly replenishing its atmosphere, and it's kind of reached an equilibrium. If for example you could somehow patch the northern part of the magnetic field on Mars, the actual pressure over time would build up, and then maybe it would be possible for a human to walk on the surface of Mars with just a big coat and a mask or something. You know what I mean? And if that could ever be done, we'd be able to bring over a lot more people to work there. It'd be a bit like working in Antarctica, if you see what I mean, as opposed to needing to have a huge spacesuit on you every time you went outside. It's mainly to do with size, position, and also catastrophic events that have happened.
How they formed and stuff, yeah. That was a really good answer, yeah. That was very interesting, even for me. We've got a few more good answers. How long is the trip in time, not in distance, from Earth to the ISS? They know that you obviously work with a lot of the astronauts, so how long does it take them to get to the ISS, and what are the historical methods and what are the current methods of getting there?
There's actually multiple different launch trajectories you can go on. I think the fastest it's ever been done is about 2 hours or 2.5 hours or something, and that's where And these are amazing if you ever get to watch these online. Basically, what happens is the Soyuz rocket is sat there waiting. The ISS comes over the horizon and they launch, and it goes off after it, if you see what I mean. And then, it releases the Soyuz and it goes and chases down the ISS. And the fastest it's ever been done is about 2.5 hours. Actually, I think they might have done it fastest with the Progress vehicle, which is the cargo version of the Soyuz. But normally, I think it takes. It depends on the launch vehicle, and it depends on where you launch from. The cargo vehicles usually take their time to get there because there's no kind of launch, there's nobody on board sitting in an uncomfortable position or anything like that. Whereas with the Progress, they're all really, the Soyuz, they're all really cramped and sort of packed in like sardines. So they want to get that journey over quickly. But there's two different ascent profiles with the Soyuz. Which up until recently the Crew Dragon started flying, the only method of getting humans to the space station after the shuttle was retired in 2011 was the Soyuz, if you see what I mean, and all the other agencies were buying seats on the Soyuz rockets. They would do this, either they would do this 3-hour ascent profile, which would be where you basically chase the ISS down, or there's a 2-day ascent where you can launch any time, and then you actually have to you go up into you get up into orbit, and you have to circularize your orbit and change your orbit a few times, and then you slowly catch up to the ISS and rendezvous with it, sort of thing. The American vehicle now, the Crew Dragon, that I'm not actually sure of how long that takes. I believe the last time I watched the Crew 1 go up, I think it was like 8 hours or something. So it's not hugely, but that's a much more comfortable vehicle. You see what I mean? Yeah. It's obviously much more modern. The Soyuz vehicle hasn't really changed that much in its design fundamentally. For obviously they've done lots of iterations and improved it, and it's a very reliable, stable vehicle. If you see what I mean, it's but the new Crew Dragon has got lots of space in it. They can actually unbuckle, they can walk around and do stuff, and there's a toilet on it and everything like that. So it's a bit more comfortable than the Soyuz, so that they can afford to take a bit more time. But with the taller astronauts, for example, like Paolo Nespoli, he's like 6 foot something. He must have been in a very the taller you are, the more uncomfortable the Soyuz is, if you see what I mean. So that's why they have this kind of rapid ascent profile, so that they don't have to spend so much time in a cramped condition, which is uncomfortable, sort of thing.
Yeah, that was a great answer. There's a question from Deirdre, which is, can I work at ESA from Ireland, or would I have to move? Obviously there's a lot more remote working jobs now, but would there be like an office in Ireland for ESA?
You know what? I don't know the answers to that. There might be. I think I know most of the one that's closest to you is in Harwell in Oxfordshire in the UK. That's the one I think is geographically closest to you. But it depends on what kind of role you would work in ESA. Like if you were in like a technical role, you'd probably end up in STEC in the Netherlands. If you were in like a spacecraft operations role, you'd end up in ESOC in Italy. If you were doing more of a managerial role, you might end up in the headquarters in Paris, sort of thing. So there's all these offices dotted around. But you are right. Obviously the pandemic has changed working practices a lot, and I've actually only been into the office about 4 times since March 2020. And yeah, there are lots of roles now, and the rules for our working have been relaxed a lot. So now, if I wanted to, I could go home and work from the UK. Just remote working like I am at home. But obviously my whole family's here in the Netherlands now, so I'm choosing to sort of not do that and stay here with them. But there's lots of sort of younger people at ESA who have families in different parts of Europe and stuff like that, and a lot of them went back home. Ones that are unmarried and don't have kids, that they often went back to their own countries to work. And the remote working environment at ESA now is really been honed and polished. So that kind of thing can happen, and I hope that after COVID is over, it doesn't all just get wiped away, if you see what I mean.
Yeah,
and I
absolutely.
hope that
Yeah.
some of the the benefits of working remotely and not traveling and not polluting the atmosphere as much are going to sort of stick around. But yeah, I expect if you do work for ESA, you probably will at some point or other have to end up working at an ESA facility, if you see what I mean.
Yeah.
So yeah.
There's a good question from Daniel, which is, are there plans to extend or replace the ISS? So I know there's been a few different sort of Earth orbiters that other than the natural ones, but like Mir, for example, was decommissioned and stuff. Are there any plans to extend the ISS beyond the extensions that it's already had?
Yeah, so this is all still very up in the air, and I don't. There might be some decisions that have been taken about this, but I'm not aware of them yet. All I know is that the ISS, the agreement for the ISS, the cooperation between the Russians and the Americans, ends in 2024, which is quite fast approaching, and all the flight plans that I've got end in 2024. So I can't see further into the future past that, if you see what I mean. And there's a couple of theories about what might happen to the ISS. One is that it's turned over to a commercial organisation, and a commercial organisation, I don't know, like a Lockheed Martin or some big aerospace company, would then take it over and run it. I'm slightly nervous about that kind of thing happening, because I don't know whether, if you put that much hardware and that much safety critical stuff in the hands of a company that wants to, use it for profit, whether the due diligence and the care and attention would be there in the same way that actually, a intergovernmental agency like ESA, and NASA and all of the international partners put into it. You see what I mean? If it was put in charge of just one company, my personal feeling myself is that I'd be worried about the safety aspects of it, and about whether corners started to get cut and things like that. So I could be proved wrong. I don't know. And I hope if that does happen, I hope that it goes very well. And obviously the ISS is, there's definitely lots of commercial opportunities for people to conduct their own research on their own costs in that kind of setting. The other idea I've heard is that it could get boosted up into like 1,000-year storage orbit. So they attach some vehicle to it and they blast it, and it goes right up into like out past geostationary somewhere, if you see what I mean. And they just keep it there forever as a kind of like a monument to. They might fold down all of the solar rays or something. And the other one, and this is the one that I kind of feel might happen, is that it will be allowed to burn up in the atmosphere. They'll sort of allow it to sort of because it's very old now. The ISS is 20 years old. It's some of the components, like the Columbus module, was manufactured in the 90s. If you see what I mean, that's the European module, and the integration aspects between the US segment and the Russian segment have lots of foibles and lots of little tweaks and things you've got to know. For example, if there's an alarm going off in the Russian segment, it cuts off voice communications between the Russian segment and the US segment. So they've got to make sure they switch the alarm off before they try and talk to someone in the. And there's lots of little ifs and buts like that about how the ISS is sort of patchworked together, if you see what I mean.
Yeah.
And I actually think that if you wanted to carry on doing microgravity research, there are now much better designs than a much more sort of up to date, like really 21st century technology sort of thing that can be applied now. Like if you look at companies like Bigelow Aerospace, they have these gigantic inflatable modules which allow you to sort of like with quite low mass launch something huge and then expand into this huge great it's called the Olympus module or something. I think that got it. And there's some designs for Mars missions that involve two of these things. So yeah, the actual answer is I don't know, but those are the three possible options. If it does get allowed to burn up in the atmosphere, then a lot of people will want to try and go and see it and stuff like that, because it will be a huge fireball, if you see what I mean.
Yeah, absolutely, because it is massive at this point.
Yeah.
Well, thank you very much. Those were great answers, and it was great that so many of our attendees were able to put their answers in. That's all from us here in Antrim. We hope you enjoyed our live jam stream today, even with all of its technical difficulties. We'll be sending out a survey in the coming days, and we'd love to hear any feedback, anything you think we could do better or that you think was really good, and that'll help us with these events in the future. We did implement some of your feedback from the last one, but we'd love just feedback from everyone. We're really sorry that the tech didn't work as we had hoped for the second Mission to Mars workshop, but we will get the robots back next month when the tech is fixed, and hopefully you'll all be able to work together on it the way that we had planned to. But enjoy the rest of your weekend, and that's all from us.